The hitch is, what they're looking at, early forming stars, are not visible to the human eye.
At optical wavelengths, you don't see stars until they are relatively well evolved and they have dispersed all of the material and the dusty interstellar medium around them.
Everything that's warm, or at least above absolute zero, glows. For example, the sun glowing at 6,300 degrees Celsius, 11,300 degrees Fahrenheit, is an example of visible or optical light. The extremely cold interstellar dust that surrounds newly forming stars measures or glows as low as minus 260 degrees Celsius, minus 430 degrees Fahrenheit. This light irradiation is termed sub-millimeter light. Similar to infrared light, it's a longer wavelength radiation that requires a special camera or detector to see.
So if you're trying to understand the formation of stars and the early evolution of stars, you have to look at stars at a time when they're much younger. And it's at those stages of their evolutionary cycle when they are heavily enshrouded in dust.
Visible light pictures of the Eagle Nebula taken by the Hubble Space Telescope show the interstellar dust. But where are the new stars? The key is looking at sub-millimeter imagery, exactly what BLAST is designed to do.
You want to go look for places, for clouds of dust, where the dust has been warmed up. It's been warmed up by these supermassive, super bright stars that have just formed inside there.
To find these places, the BLAST telescope's primary and secondary mirrors receive and focus light into a cryogenically cooled detector system, where sub-millimeter light is detected at 3 different wavelengths. The data is then converted to a 2-dimensional map of the universe at sub-millimeter wavelengths. From there, BLAST scientists will identify distant galaxies to pinpoint.
To map a 2-dimensional region on the sky, we will scan in azimuth, or essentially just scanning left to right, and then slowly we will be scanning upwards as well at the same time in a certain pattern. We need to be able to point the telescope to about 1,000th of a degree accuracy.